Hello friends, in the last session we have covered the basics of MAC address format and the significance of ARP table. We have also discussed the working of ARP protocol, that too how datagram is moved within the same subnet. In this session we will discuss how datagram can be moved across different subnets. Now we will discuss another scenario wherein the datagram is crossing the subnet border, that is traveling across the subnet. Means source and destination belongs to different subnets. It should now be clear that how ARP operates when host wants to send a datagram to another host on the same subnet, which we have discussed. But now let us look at the more complicated situation when host on a subnet wants to send a network layer datagram to host of the subnet, that is across a router onto another subnet. We will discuss this issue in the context of diagram shown, which shows a simple network consisting of two subnet interconnected by router. We are having these two subnet, one subnet having address 111-111-111/24 and another subnet 222.222.222/24. These two subnets are connected through a router. There are several interesting things to note about this particular illustration. Each host has exactly one IP address and one adapter. Here each individual host having the one IP address and one MAC address associated with the adapter. These are the adapters. Each and every host is having one IP address along with one MAC address associated with the adapter. But router has an IP address for each of its interface. These are the two interfaces of the routers having the IP address and associated with each, and there are two adapters at each interface. For each router interface there is also an ARP module, that is an adapter. Because the router in the figure has two interfaces, it has two IP addresses and two IP modules and two adapters. As this router has two interfaces, it has two adapters as well as two ARP modules. Of course, each adapter in the network has its own MAC address. Also note that subnet 1 has network addresses as 111-111-111-/24, and subnet 2 has an IP address 222-222-222/24. Thus, all the interfaces connected to subnet 1 have the addresses of the form 111-111-111-XXX. Similarly, all the interfaces connected to subnet 2 have addresses of the form 222-222-222-XXX. Here, host A needs to send an IP datagram from host A to host B, that is crossing the subnet. We will see how this happens. Here we will assume that host A knows the host B's IP address. Also assume that A knows the IP address of first hop routers. A knows the IP address of first hop routers and A also knows the IP address of destination. Similarly, A also knows this first router's MAC address. Now we will try to simulate how one host in one subnet sends an IP datagram from one subnet to another host belongs to another subnet. Here, this host A wants to send a packet to host B through router R, and here host A as well as host B belongs to different subnets. And these are the MAC addresses associated with each of the adapters connected to each individual host and the router. Now let us examine how a host on subnet A sends datagram to a host on subnet B. Specifically from host having IP address 111-111-111-111 will send datagram to another host having IP address of 222-222-222-222. Here the sending host passes the datagram to its adapter. This is a sending host. Passes the datagram to its adapter. This host passes to adapter as usual. But the sending host must also indicate to its adapter the appropriate destination MAC address. This is a frame which consists of source address as well as the destination address. This particular frame is sent to its adapter. It must also contain the MAC address of destination. What MAC address should be the adapter uses? You might be tempted to guess that the appropriate MAC address is that of the adapter for a host 222.222.222.222 because this is the host destination host. So the adapter address associated with destination must be included in the frame. But this is not true. This is wrong. If the sending adapter were to use that MAC addresses, then none of the adapters on subnet 1 would be bothered to pass the IP datagram up to its network layer. Since the frame's destination address would not match the MAC address of any adapters on subnet 1. If this MAC address would have been associated with this frame, then this particular frame would not have been forwarded over the subnet 1. If we look carefully at this figure, we see that in order for a datagram to go from this 111-111-111-111 to a host on subnet 2, the datagram must first be sent to the router interface. Ultimately, when this host needs to send a datagram from A to B, it must be first passed through this router. So it must be addressed to this router interface, that is 111-111-111-110, which is an IP address of the first hop router on the path to the final destination. This is the first hop router on the path to the final destination. Thus, the appropriate MAC address for the frame is the address of the adapter for the router interface 111-111-111-110, which is nothing but E6-E9-00-17-BB-4B instead of the final destination MAC address. Then how does the sending host acquire the MAC address, this particular MAC address? Here the obvious answer will be the ARP. Here, host A creates an IP datagram with source address A and destination address B, and it simply inserts this frame, and here you can see that the MAC address of source is same, that is 74-29-9C-E8-FM.55, but the destination MAC address is this, the address associated with first hop router, not that of destination. A creates a link layer with R's MAC address. This MAC address, not the destination MAC address. Once the sending adapter has the MAC address of this particular router's adapter, it creates a frame. That is, a datagram is inserted in the frame, and the frame consists of two MAC addresses, one of that of source and destination MAC addresses of that router's interface. This datagram addresses to the destination 222. This is the IP address of destination. This is an IP address of source. This is a datagram which is inserted inside the frame. The frame has been created at host with source MAC address and the destination MAC address, that is the address of the router's adapter. Router adapter on subnet 1 sees that the link layer frame, this particular frame, is addressed to it, and therefore it passes the frame to the network layer of the router, and thus the IP datagram has successfully been moved from source host to router. This frame has been moved from source to the router, because here router sees that a particular frame is addressed to this router, hence the frame has been successfully moved from A to router. On receipt of the frame, the router extract the datagram. Now, but we are not finished here. This is halfway. We still have to move the datagram from router to the destination, because as this datagram is finally destined to host B, we are in halfway. We need to move this datagram from R to B. The router now has to determine the correct interface on which the datagram is forwarded. Once the datagram has been received by the router, it is up to the router's forwarding table to decide the correct outward interface over which that datagram must be forwarded. This is done by consulting the forwarding table at router. The forwarding table tells the router that the datagram must be forwarded via router's interface having address 222.222.222.220. This interface then passes the datagram to its adapter, which encapsulates the datagram in a new frame. Hence, this extracted datagram is then again encapsulated into the frame created by router having the source MAC address as 1118-23-F9-CD-06-9B and destination MAC address as 49-BD-D2-C7-56-2A. This particular datagram has been inserted into the frame or encapsulated into the frame with appropriate source as well as destination MAC address. Here the source MAC address is the MAC address of this particular outward interface, that is, and the destination MAC address is of the MAC address of the final destination. Here the frame is then traversed from router's outward interface and to the final destination B. On receipt of the frame, host B extract the datagram and it passed to the upper layer protocol. This is how the packet, that is IP datagram, is traveled from host A belongs to one subnet to host B belong to another subnet through a router. In context with the link layer, so far we have covered the broadcast networks, multiple access protocols, switched LAN and link layer addressing. Next we will explore the Ethernet. Thank you for being with me. Thank you.